So the next thing we're going to get is some notation regarding sums. And I've used a plus sign here, but the notation is different. And that is, you might have remembered this sigma notation. I'm sure you've seen it at some point in time. Um, but just so that we're all on the same page, if you have a sequence of numbers and you want to find the sum of all of those numbers, the way that we write that is, as follows on the middle of the page. And so we see that we let this index I run from 1 to n, and we just have to write x sub I. And what that means is I want to add up every xi where I is equal to 1 all the way up to n as listed. And so this is summation notation, and the index I is not only an index variable as we use in programming, but it's the index of summation. And this should remind you of something that, or it will once you see it if you're in 1105, but this sounds like loops in programming. And in fact, it is. It's the same concept. And so if I want to do this within Java, I can create this summation notation in Java. And what I do is I create a loop structure. If you haven't seen that, you won't be tested in this class on the loop structure. But for those of you that come with programming experience or are learning about these same things in 1110, it's important to make those connections. So if you wanted to automatically create this loop sum, the way that you would do that is you would use a for loop. And so you'll see that I have for, and I'm letting my index variable I run from 0 to I less than or equal to n in this example. And I'm going to add to the sum, I'm going to add a new element each time. Okay, so let's look at some other examples. If we have a 0 set to 1, a 1 set to 2, a 2 set to 4, a sub 3 set to 8, and a 4 set to 16. First of all, in the chat, if anybody identify what they think A5 would be and what my rule is there? Nice. Yes. So I'm looking at powers of 2. So A sub n is 2 to that nth power. Well spotted. So if I wanted to represent that in the sum of all of those in summation notation, rather than writing out A0 plus A1 plus A2 plus A3 plus A4, I can do that concisely using summation notation. And the way that I do that is as listed on the screen. So I use that sigma notation. I let the index variable run from 0 up to 4, and I get the following. So it adds up each of the pieces in turn, which sum to 31. And that's a fun, well, it's a fun fact. If I added 32, I get 63. So I'm always one short of the next one above it. That's a neat piece of powers of 2. All right, so here's another example. I don't have to use a subscripted variable. I can also do a sum of some quantity, right? So I can sum all I when I let I run from 0 to 4. And in that case, I just evaluate what that would be. Just as I summed A sub 0 plus A sub 1 plus A sub 2, this is saying I'm going to sub I equals 0, I equals 1, I equals 2, I equals 3, all the way up to 4. And so, yeah, sure, go for it. You can do the quick check for me. 28 plus 3, 31. I think I'm good. Somebody can check and confirm if I'm wrong. Okay, it's possible. I don't mind being pointed wrong. I'll fix the slides and repost them if you point it out. Um, Always good to double check. I take no offense to that. Okay, and so if we add those up, perfect, thank you. Uh, so here's one for you. So what is the answer to this one? So now I want to take the sum of I equals 1 to 3 of the squares of I. So I squared. So it's going to be 1 squared plus 2 squared plus 3 squared. I think I heard an answer. It was very fast. Yeah. Yeah. So 14. And you got that because it's the first term would be 1. The second term is 2 squared, or 4, right? And the next term is 3 squared, or 9. And so it's 1 plus 4 plus 9, or 10 plus 4 is 14. Perfect. If you wanted to find that because you didn't want to do the math in your head, you could also do that in Java. And so this is just a bit of code. This way, if you think about what you want to do when you're problem solving in the future in programming, and you say, yeah, what I want to do is sum all those terms. I know we talked about that in discrete. How would I do that? Now you've got some code to fall back on. Way better than anything that you're going to get from all the many sources on the internet. Okay, so sometimes it's common when we're uh, programming that we want to do things that involve double sums. Okay, so imagine, and these are called nested loops when we're programming, but consider one of the most common ways this comes up is when we have a table of elements. And so we're going to use the term a sub I comma j to represent the ith row and the jth column. Okay, so say we have a table that has 3 rows and 4 columns. You can sum those elements in the table. That's a common thing that somebody might wish to do. And when I use the term nested loops, what I'm talking about is a loop inside another loop. And so a double sum is a sum inside of another sum. Okay, so we can do that. So say we have this table that has 3 rows and 4 columns. We can sum we can sum the entire table by either summing each of the row sums. So look at the sum of each row, and then sum each of those rows. So the sum of row 1 plus the sum of row 2 plus the sum of row 3. Um, and to represent that, what we're actually asking for is we want both I and j to move, right? We want the rows to go from row 1 to row 3, which is letting I run from 1 to 3. And we want the columns to go from 1 to 4. So we want j to go from 1 to 4. And so we represent that mathematically by having a sum of a sum. Okay, and so that's this first piece is the sum of the row sums. That internal block is the sum of the row, letting j run from 1 to 4 in the column. And so then that would just be, if we look across at that first row sums to 4, the second row sums to 8, the last row sums to 12, and that's going to return us with 24. Another way that you could do this, and this is why when you write programs, everybody's going to write something differently. These are both valid ways to model a sum of a table. And I'll show you the code for this as well. So when you sum, you could also choose to sum all of the sums of the columns. And this is somehow easier in the table that I've provided. But in this time, we're first saying, okay, I'm going to go across each of the columns, which is letting j run from 1 to 4. And for each of those columns, what I want is the sum of column j. And I'm going to get that by taking a sub I comma j. I want that for I equals 1, row 1 plus row 2 plus row 3 within that column. Okay, so in column 1, in our example, that's 1 plus 2 plus 3, 6. And in fact, I have the same numbers across. And so the column sum for each column is going to be 6. And I've got 6 of those columns. So it's 6 plus 6 plus 6 plus 6, again, getting 24. So we get the same answer no matter how we do this, but it's a different approach. Okay, so actually, I'll ask you, I've covered up that final answer, but if you've had a little bit of familiarity or you just want to take a guess, it's okay to look at code and take a stab at what you think it's doing. So I'm doing one of these two with this code. So I've created a table it's a two-dimensional array is what I've used in Java. And I've created it such that the rows and the columns look like the table that I have described here. And then I have a nested loop structure. So it's a double sum that I'm creating. And what I've done is I've let I run from 0 to less than 3. And there's a piece there that I'm kind of hand waving over, and that is indexing in Java starts from 0. But essentially, I'm trying to do the same thing of letting I run from the equivalent uh, of 1 to 3. And then internally, I have J running from 0 to less than 4, and it increments each time by 1. And then I'm just going to sum up whatever's held in that position, Aij. So this, yeah, so here is the creation of the essentially this table here. This is looping J from 1 to 4, right? And and what that whole thing does is it finds, oops, I'm on the wrong screen. I have to look to the left to do that. The sum of row I. So let's say, okay, so let's say we are going to start with I equals 1. When I equals 1, that means we're going to be, everything we do is going to be in this top row. And if I let J run from 1 to 4, and I'm going to sum up each of those, what I do is I say, so I already know I'm at A, I is 1. So I'm going to sum up that A. Well, I can't promise that I can write neatly. I apologize. I'm using a trackpad here. A1J. Okay? And so I'm going to let J now run from uh, so that's all in here. So I'm going to let J run from 1 to 4. And what that means is the first time when it's 1, I'm going to add the 1. Then the next time I'm pulling in A1, 2, then A1, 3, then A1, 4. Okay? And so that, when I add those all up, that's that sum of row 1. And so when I add that up, that's where I get the 4. When I equals 2, that's that A2J. We're going to let J again go from 1 to 4. And this time we're going to get 2 plus 2 plus 2 plus 2, or 8, right? And so that's how we get that 8. And we do the same thing for row 3. Does that help? Whoever's asked the question, hopefully. And these, again, these double sums and this bit is still foundation, so we will have time in the tutorials to kind of come back to that. But a lot of this is actually meant to be a bit of review from material in the past. Oh, so I see a question by Daniel. So I is referring to the row and J is referring to the column. Yes. And so that's right here. So it's the ith row and the jth column. Jth is very hard to say. You can try that in the comfort of your own home this morning. Okay, thanks, Maxim. That's great. I'm glad that helps. And feel free, a lot of these, I know we're covering them right quickly. And so if it's an area that you find that you not struggled with, but like it's been a while or you haven't thought about it for a bit, feel free to bring it up in the tutorial sessions. That's what we're there for.